Good morning, everybody. Cheers. Freshly brewed coffee. Yum. Been hanging out for this, waiting for it for so long. So, I wasn't going to stream today. Been super busy at work, been doing really long hours, and really tired, but my body clock has decided to, every single day, 4:45, I'm awake. Like, cannot get back to sleep. Like, awake. So, I was so exhausted last night that I really thought I was going to sleep in this morning. But nope. 4:45, bang, eyes are open, brain is going a million miles an hour. So, I came into work, and I was just going to work this morning. I wasn't going to stream still. But the other day, I was cleaning up some cables and stuff, and I remembered that I had, what did I put the other one? I had some of these HDMI to USB things. That's the CamLink one. And I also had a cheap Chinese one. And so I thought, hey, I wonder if I could get my BlizzardS3 HDMI to output through this as a webcam so I could capture it in OBS, because last week I had to have the monitor behind me because the DVI output from the BlizzardS3 is not actually producing a strict HDMI output, right? It's DVI output, not HDMI, and it's not the right resolution. So my ATEM Mini and my other capture devices won't actually detect it as a HDMI output. So anyway, I tried the CamLink and that didn't work, but I tried my other one and it did work. And so I can capture it into OBS. So I thought, oh, maybe we should do some cool stuff. So the other day, after the stream, I started playing around with adding more features to the graphics library, which I'll show you in a moment. And then I stupidly, just, because I was trying to avoid doing some other stuff, decided to start playing around, see if I could get a 3D cube spinning on the screen. I had to read S3 graphics a few times. I kept reading 30. What? Quindle? What? So anyway, started playing with that, and I thought that'd be a cool thing to continue playing with on stream. So it's not going to be a long stream today because I do have stacks and stacks at work. Yes, S3 graphics, I know. I used to have one of their very first graphics cards. God, they were expensive, weren't they? I can't remember the name of it, what I had. But it was, I remember it being like a $900 graphics card at the time. And they had one of those, like an S3 chip on it. Anyway, and it was just they were just 2D graphics cards, right? But they were hardware accelerated 2D graphics cards. I think the Trio was a later one. I can't remember what it was called. So anyway, I'm streaming. I shouldn't be. I've got piles of boards to test and clean. I've got to run the line again today. Anyway, but this has been fun playing around this. So, but before we get on to that, I wanted to show you that although shock horror, I might do another tiny watch revision before I make panels, although I've got panels ready to go. I actually pulled them from JLC. Anyway, I'll get onto that, but I wanted to show you, I've again been wasting time on this. I call it wasting time because I've had other important things to be doing, but there is a tiny watch. It's in half a band because I can't find the other half of that band, but that's an Apple Watch band. I was wearing it yesterday I took my band off. So it's a little bit fatter than the Apple Watch. Hang on, let me just set my watch off. And a little bit fatter than the Apple Watch. Not that much, because the Apple Watch is curved on the bottom, right? It's actually only a couple of millimeters thicker. Almost the same size. There is actually a tiny watch in here. Unfortunately, my clipping broke. There's a tiny watch in there, which works. This is the back of the case. You can actually wear it. The band just, they slide in. It doesn't have the magnet stuff, right? And it can fit a battery in here, but it's only this little guy here. But it does actually fit, but it's a useless battery. It's like 120 milliamp. It says 200. It says it's a 200 milliamp hour, but there's no way it's more than 100. So I only started working on the case yesterday. No one had seen the case. I did post some pictures in Discord yesterday. So the problem is, like, it's really tight in there, obviously. Sizes and everything. Well, no, yes. Well, I don't want to wear a big bulky watch. I mean, I could make this bottom of the case a bit bigger, like, 2 millimeters bigger, and fit a bigger battery in. The problem is the buzzer, which is, hang on, I'll show you here. So there's the buzzer, right? It's a 5x5 millimeter buzzer. It actually sits on the same side as the I2C chip from the cable from the screen, and because of the buzzer, it doesn't allow the cable to sit very flat, and so, which is a bit of a problem, and it gets in the way. And I found some smaller buzzers, but it means I don't want to risk making panels to use a new buzzer that I haven't tested, just in case the buzzer ends up being too quiet or whatever. But I don't really want to do another revision again, because it's like, costs a fortune, like the parts on the board and stuff. And maybe I could just do a revision just to test the buzzer. I don't know. But anyway, making a case has been such a painful process. So the board sits there, that's the screen inside there. The screen actually sits in on the top, snaps in, there we go. So that's actually, the case is in two halves. That's the top half of the case. And yeah, broke the clips. Anyway, they weren't strong enough. That's the bottom half. It's together. The other problem is so the buttons, the idea was always to have a separate button that you push, that pushes the actuator on the actual watch button, because these don't stick out, or they stick out, half a millimeter. They were designed to be pushed by another button. But 3D printing isn't really good enough to do really thin walls to hold the buttons in without breaking the edge, and otherwise I need to make it bigger. I'm not making injection molding cases. This is a DIY open source watch. I wasn't even going to make a case at all. I've done a lot of the work already for this watch. I figured the community could contribute a case or cases, but cases, I know I just said that like that. But I was curious to see if I could, but anyway, I've wasted a lot of time going down this rabbit hole. Obviously a machined one would be really cool. Could make them out of aluminium, could machine them out of aluminium. That would have enough strength. But 3D printing isn't good enough to make buttons and to do the thin enough walls and stuff that I need. Maybe resin printing is, I don't know, I don't have a resin printer. But anyway, I just thought I'd show you that it's progress. The watch, it's all validated and everything works, which is great. But yeah, kind of, I need to focus on other things at the moment. So, I'm going to say hi to everyone in the chat, then I'm going to answer a question from John Clayton, and then I'm going to show you what I've been working on. So, Christian, good morning. Yumbo Prime, hello. Sam, hi. Yes, such a sleep in at 7 AM, except that's not when I wake up. John, hello. David Esser, hi. Antonio, hi. Beata, Sean, Alex, Christos, hello. Rota, hey ho. Johnny is here. Quindor is here. Intimate Tech. SDG Electronics, hello. Same thing here. What? Who's the same thing here? What did I miss? Excuse me. Otaku, hi. Scrolling, lost it. No, yep, Sid, hello. Andy, Hi. Bruce, hello. I think that is anyone that's chatted anyway. It says there are 44 people, but, oh, Embedded Hobbyist, hello. Oh, Embedded Hobbyist got a new PC. Hope it was a Mac. X-Micron, hello. I should rest more often. I try. My body and mind wakes up. Doesn't matter how tired I am, I'm up in the morning. I'm a morning person, it seems. I used to be an evening person, but now I'm a night person, but now I'm a morning person. So it is what it is. Okay, to answer John's question, he asked earlier about getting bit streams onto the FPGA side of the Blizzard. Can you program the ICE40 from the S3? So you can send bit streams up. You can put as many different bit streams as you want in the flash of the ESP32 S3 side in the file system, and then you can, on the fly, load them into the ICE40 as you want. So you could have different bit streams for different bits of code or whatever, but what you can't do is actually generate bit streams on the fly on the S3. You need a computer with either an open source toolchain, which is a very large, complicated, multi-step toolchain, or you need to be using, obviously a third-party proprietary FPGA tools from whatever your vendor is. So there's no pipeline at the moment to take a bunch of Verilog or VHDL code. Is it code? It's not really code. It's whatever it is, and then have that be compiled into a bit stream on the actual ESP32 S3. That would be awesome. It would also be extremely slow, right? Like unusably slow. I am using the Ice Storm toolchain. Yeah, the Yosis, Next PNR, and all that stuff. Yeah. RTL or HTL? What's RTL? Hate the switch from night to morning. I didn't have a choice. It just I having kids kind of. And yeah, like Yuz is absolutely a night person, not a morning person. Like, if the whole house could allow her to sleep, she would sleep all morning. Like, but I can't. I'm just bang. I'm awake, and I'm awake. I'm not like I'm awake and I'm drowsy and I want to stay in bed and whatever. I'm like, up, let's go. Yeah. Alex, not 7 or 8 weeks later. Resistor, transistor logic, don't know what. So HDL or VHDL and Verilog are the hardware descriptive language. So HDL stands for, isn't it, for hardware descriptive language? Isn't that actually what it stands for, I think? I don't know what RTL, I've not heard that, but I'm sure it's just another acronym for whatever. I'm so much a night person. I often see it become 6 women's own. Yeah, I used to do all-nighters a lot, like multiple days in a row. I used to get into like coding frenzies back in the day when I was younger, when I used to do a lot of coding. And yeah, like I'd go to work on a Monday and I'd come home and shower on a Wednesday. Like, and yeah. 26 years night shift. Yeah, well, that's your daytime when you do night shift. Register transfer level code. Okay. I don't know if it's, I don't believe it's possible to do any type of conversion from the definitions to bitstream on the S3. I mean, a lot of that tool chain is Python. I think it might all be Python. I don't know, but that doesn't mean it'll run in embedded Python, and even if it could, it would be, yeah, ridiculously slow. Okay, so I hope that answers your question, John. So let's continue on with where I was. It's not going to be a super long stream today. Too low memory to do that. Not sure about possibly, but you got to remember, I mean, you can get technically up to 128 gigabytes of memory sorry, 128 megabytes of memory on an ESP32S3. I mean, you could, I'm sure the pipeline could be changed. Anyway, it doesn't matter. It's not, you can't do it. It's not happening. I'm not making it happen. I don't even understand how the tool chain works. It's just magic. Remember, my FPGA skills are probably 1 out of 100 right now. So, yeah. Are there any new updates to this? So, no, the FPGA logic is the same right now, although Michael has been working on frame buffer stuff on the ICE side. I have redesigned the BlizzardS-3 to have PSRAM on the top to make it a single-sided board. Right now, it's still... Whoop. Right now, on the current version I'm using here, the PSRAM for the ICE 40 is on the bottom. It was always going to be a something that the users could add on themselves, and I wasn't going to ship it with it. But I have actually managed to put it on the top using a different PSRAM package, which unfortunately is 3 times the price, but it's small and it fits on the top. So Michael has been working on, or looking at frame buffer, which allow us to do 640 by 480 with 16-bit color, and possibly up to 720p with back to 256 color palette. 8 megabytes of PSRAM. The PSRAM isn't the amount of RAM isn't the issue, it's the speed. It's how fast we can get data out of it. It's quad SPI. Octal PSRAM is like $8 US a chip, $9 US a chip, and it's also BGA and massive, and I can't fit that on the board, top or bottom. Octal would obviously give us twice the speed, but yeah. Are there libraries in C for the FPGAs? What do you mean for the... I mean the libs in C++ for the FPGA. The FPGA is running bitstream, like gateway. It's running, it's hardware, it's not software. The FPGAs. Like we're not running, I mean we could be running a RISC core inside the FPGA and having that send DVI out or whatever, but that's going to be even slower, right? Because then it's translation on translation or whatever. But yeah, so the PSRAM is 8 megabytes. What's on there right now is 8 megabytes, but it's on the bottom because it's a larger, it's a SOP 8 package, which is too big to do on the top. So Doom is already done on the ICE 40. Like I could put Doom on, although it was set to work HDMI. Anyway, that's been done, and Doom on the S3's been done, right? It's just having some glue that makes Doom on the S3 talk to the file format on the ICE 40, because right now we're just using a palette, 320 by 240, and it's just a 256 color palette, because we're using the SRAM inside the ICE 40 at the moment for the frame buffer, which is only 120K. No, it won't run Crysis. Okay, so to show you what I got up to after the stream, I just realized I don't have audio in that channel. Hang on. That's interesting. Let me see if I can get audio in that one. No. Yeah, I know. There's no. I know. I haven't got it in there yet. Hang on. Okay, we've got audio in here now. I think. I hope. Can someone just confirm there's audio? Okay, cool. So after the stream last week, when we were playing around with some fonts and stuff, I've now got circle, fill circle, I've got rectangles, filled rectangles, I've got triangles and filled triangles, I've got vertical lines, horizontal lines, I've got just a line routine, an arbitrary line. The horizontal and vertical is where you just pass an X or a Y and a length type thing. I got it's the same fonts as before, but I can now gradient them, whatever else. And then I've also got N polygons. So we all know what a polygon is, right? It's just a multiple lines joined into a shape, but N meaning you can have as many sides, many lines as you want. So all of those are in there, and it's just all in CircuitPython library, right? I'm doing this in CircuitPython just because I'm just hacking, right? Like if I was really taking this seriously and wanted to build a really fast library, I'd be doing it in C++, but that wasn't my point. My point was just to have some fun, and that's what I'm doing in CircuitPython. No rhombus. I still couldn't get their bitmap stuff working. I couldn't work out what format specifically, or what they were doing. I didn't want to just use BMPs. Let me just come back to, okay, I'll show you. I've also got this set up here. Right, there we go. It's me again. So I've got a small version of that screen on here so we can code live. So I didn't want to have to, every time I wanted to see if I could put a bitmap on the screen, take my original bitmap and then run it through some type of tool to get a certain version of it out that I can then load. I want to work out how to actually get it working properly. I don't know why I was having so much problems. The GIF loader should work. The PNG loader should work. I couldn't get them to load. It's not like I couldn't get them to display. I couldn't get them to even recognize any files. So I don't know what the deal is there. I will get to that. But I got this far, and then I got the n-gons working, and I thought, if I can do an n-gon, I wonder if I can do a cube, right? So I've got a whole bunch of stuff in here. I'm going to just comment that out, and and I cleaned up the library massively. So it's all in a library now, which I'll get to. I rewrote it all. I want that, and I want that. So now, if I save this, and it reloads automatically, we've got a spinning cube, and it's cycling color. And it's not very fast. But that's actually a cube. It's a spinning cube, and it's actually using some really bad 3D maths. So I've got a Blizzard graphics library now. And inside the graphics library, this class here, I've got, so if you look back at my code now, it's not all in here. This is all the old code of all the stuff I had in there, right? All the crap from before. These are just the tests that I was doing, right? Like here's a fill triangle with a fill triangle label. Here's a V-line, whatever, you know what I mean? So this here was that demo before. But everything now is you just initialize the graphics library with a resolution. And that's it, right? Now for the Tesseract. So inside the graphics library, that does all of its setup. It does all of the SPI stuff, which pushes stuff to the FPGA. It does everything, right? So you can build the palette, you can push the palette, you can push the pixels, clear the pixels. I'm doing a nasty clear pixels right now. I'm not zeroing them, I'm just recreating it. Just for performance point of view, but that's also a probably a potential memory performance hit. And then you've got all the graphics routines. Cube in 1 or 2 seems like a cube. No, we'll get to that, but no, it's not just in. It's a proper 3D representation of a cube in a 2D plane, obviously. Anyway, so lots of all the different things here. And then I created the polygon one. Where's my polygon? What? Here we go. Created the polygon, which closed itself, and I thought, a cube. So what I've done is I've got a vertex, created a vertex class, which obviously just stores, which manages vertices for rotating them and converting from 3D back to 2D space. And then I've got a cube I've made, just as a basic thing, right? A cube is a defined shape. And then the cube has a rotate and once it goes through and recalculates its points, which is the slow part, because it's doing lots of cos and sine, which is not fast, especially in Python, but on a microcontroller. And yes, I could implement a lookup table for all of these, which would make them faster. Beyond me at the moment. It then just literally creates a polygon for every face and draws it, or for each, you know, thing. So it's a I need a good self.y cough. What? So that's basically it. That's all it is. And it draws a cube, and so I can add a second cube. Whoops, wrong line. Now we've got 2 cubes, right? So all I'm doing is passing in what the X and Y position of the cube is, what its color is, its starting X and Y rotation. I need to add a Z rotation as well, and what its size is. This is a size. Right, I need an FPS counter. I was going to add that now as well. So there's a few things I want to do. Right now I'm only rotating on the X or the Y axis. I could actually rotate on the Z axis. So I want to add rotation on the Z axis. And also I want to add we should start with a frame per second counter. So let's do that now. So up here I'm going to create a last frame time new frame time. Did I just say right? Trime. I think I did. Zoom. Do you want the is that better? Sorry. Okay, so I want to say I want to say last frame time equals time dot time. I think. All right, I'm just making this up as I'm going. New frame time equals time dot time minus last frame time. I was talking more about the cubes, but yes, that is better. Could make the cubes zoom in. Oh, I can make them move. Sure. I mean, I can. Well, technically they'll scale. They won't move. But that's another thing I want to. I mean, right now we're just playing with a cube, but I'd like to. Right now we're playing with a cube where the center of the cube is its position and everything's built around it. What I'd like to do is, at some point, come up with a scene where there's a scene and then there's a camera. And rather than manipulating the cube, which you could still do, I want to be able to move a camera so I can look at the scene, so I can look around the cube while the cube's, you know what I mean? I could build, you know, cubes like a city and move around it rather than, right now this is just an individual object spinning, right? Which isn't quite as fun, but it's a start. Got to start somewhere. What are we wrapping? FPS equals, so what do we want to do? It's the, is it? I remember, I used to do this all the time when I was doing game dev. Is it one divided by new frame time, I think. Okay. I'm trying to think, and I've got to get that into, that's going to be how long as a percentage of I'm going to print this out. I don't even know what this is going to give me. Divide by 0. What? Why would new frame time be... and then I need last frame time equals... hang on. New frame time equals that. I need to store it. And then I've got to say last frame time equals new frame time. All that give me. Still division by 0. Why can't I scroll? Ah, interesting. How can the frame time not be... Maybe I need to do it in milliseconds? Obviously, time.time's not giving me enough. I don't know if I've got microseconds. What have I got in import time, time, monotonic, and what does monotonic give me? Time dot monotonic. Okay. Maybe I want monotonic. Oops. Okay, that's giving me something now. There is no, was there a time in S? I didn't see. Don't I want a monotonic though? Frames per second. $12 frames per second, is that right? If I turn off one of the cubes, 20 frames per second? Yeah, people still do that, John. That's still a very current thing. Okay, so what I want to do, I want to stop that. I want to display that on the screen, which is going to slow it down. That's a bit weird. So I'm going to display it after. Right, so I need to store frames per second here. And I'm going to just, it'll have to be displaying the previous frames per second. That's okay. Um, 10, 10, and FPS. Oops. I'll convert this into part of the library. So it does it automatically. Okay, we should now see int is not, oh. Okay, so should I round it? That looks a bit ugly. Equals 1 divided by I want it to be times 100 int that then divided by 10. Should give me a single digit. No. What? Hey Kevin. And hey MCS1V, I'm not sure how to pronounce that. And anyone else who I've missed saying hi to. Why is that not giving me... Anyway, that'll do for the moment. Must save the last FPS value and use a high pass filter on it. Just save the last. Doesn't matter. This is good enough for the. It's just an approximation, really. Okay, now I want to add the ability to rotate on the Z as well. Step Z. Z. Step Z. This is the starting position. Rot Z equals 0. Okay, and then I also want to clean some of this stuff up. So right now, when I'm calculating the polygon, I'm shifting it for the position left, on the X and the Y in 2D space. I want to actually move that into one of the calculations up here, maybe into the 3D to 2D, because it's just, yeah. But let's just see if I can get the rotations going. That's going to error because I'm not initializing. I need an extra 0. I'm going to turn off the second cube for the moment. Oh. 4, but 3. Oh, and the rotate. Right. So when I'm telling it to rotate. Okay, let's see if I can get it to just go on the Z now. There we go. So we now got Z rotation. Hey, Jishipu. Use matrix maths. Possibly. Possibly. I was just converting some algorithms I found online. I wanted something. Remember, I wasn't going for the most performant. I was just going to, can I get a cube spinning? It was for shits and giggles that I did it at the start. I didn't think anything more was going to come of it, but yeah. Hey Kevin, yeah, that's what John was saying earlier. So we've got Z rotation now. And of course I can change the step speed. Now we've got full. Well, I can go, yeah. Now I've got X, Y, and Z. So that's all working. So I want to see if I want to just clean this stuff up. Like I want to get rid of all of this. So as I said, that's just the 2D position offset. That should really be done inside the... Hey Chris, how you doing? So this is now going to be shifted over because actually it's not. So right now for out of bounds, you can see it, sometimes it's in. I'm just spewing this out. So we'll get back to that in a second. What I want to do is I'll fix that by getting this rotation. I need to be able to pass this into here. Offset X, comma offset Y. Plus offset X, whoops, too many spaces, plus offset Y. That's now going to crap out, but I'm going to now self.pos X, self.pos Y. Okay, so this hopefully will put it back into the center. There we go. So we're back in the center. So the translation of where the item is now calculated when it's doing its 3D back to 2D mapping. So you can see here I've got a field of view and a distance. Or the field of view is really the size of the item. And so that's its size, and then this distance here is really its perspective. So if I was to make this 2 on the perspective, you'll see it's going to be quite distorted, right? It's got a really long, wide perspective, not long, wide perspective, right? And you can see it like I'm clipping the outside, and then so you can see this is doing the same amount of calculation. The XY out of bounds thing is probably slowing it down a bit. But if I make that a little bit smaller, or a little bit less perspective, so it stops clipping. So you can see that even though we're still doing exactly the same amount of calculations, right? It's the same cube.
Cian, chat has disconnected.
Okay, it's back. Don't worry. Even though it's the same amount of calculations, it's dropped like 5 frames per second. And I think that's purely because of how slow the line drawing is, or because it's literally drawing a pixel for every line, like, you know what I mean? So, like, one of the things that could be really cool that Michael and I were speaking a little while ago about would be to put a bunch of graphics routines in the FPGA side, kind of like a graphics card. So the FPGA would know how, for instance, there would be no point doing like it would need the ability to draw a pixel, right? But there'd be no savings in telling it to draw a pixel. But for it to be able to draw a line in hardware, so like we pass it a command that says here's a line and have it draw it, that would have to be considerably faster than me right now. So that whole cube, right, every frame it's having to run this really lengthy this line drawing routine. So it does a polygon, wrong window. I couldn't know what the thing is. So it's doing this complicated line routine. By the way, I modified this a bit to be able to do steep curves, steep lines. Right, it's doing this for every pixel on a line, for every line in a polygon, for every face of the cube, right? It's using ASCII to create a letter you call a shape. No, not ASCII. No. It would be there'd be a routine. Like so via SPI to the ICE. So we've got a bridge. I mean, you could create any type of bridge, but what we've got right now is on the ICE40 side, there's obviously a frame buffer that we're writing into, and it's spewing out to the DVI, and we write into it via SPI. There's no reason why part of that SPI we can just create extra commands. So we could send a command via SPI that says, draw a line from here to here in this color, and the ICE40 would fill the buffer, right? So right now I'm telling the cube, like if you look at this here, that's every face. So there's 6 faces, right? So 6 times it's got to do this, create a polygon. And every time it creates that polygon, right, it's got to go through and create a line. So 4 lines, right? And then in that line routine, it's got to go through all of this and create all the pixels. So that's just a lot of looping and repetitiveness that's all being done on the Python side, right? We could also, if we're talking about just CircuitPython, right? I could get all this stuff, do it all in C, and bake it into CircuitPython for my Blizzard board. And so all of these things could be running in C, which would be considerably faster, right? But doing it on the FPGA could be really, really cool. The guy who make the monocle have a graphics thing on their FPGA. Do they? What's the monocle? I don't know what that is. Monocle FPGA? Brilliant Labs or someone? What is, maybe something, a pre-built binary and project? I don't know what that is. Do you have a link, Chris? So I'll make you a, oh, it's a Google Glass thing, right? Okay, cool. Interesting. Anyway, I mean, obviously doing it in the FPGA side means that any code that anyone's writing could leverage it, right? But again, I'm not doing this for performance. ASICs are good for doing graphics. Use FPGA to act like a small limited. That's right, and we'd add whatever we needed to add. Hardware, monocle hardware. Oh, right, that goes on the... Right, interesting. I've not seen this. Very cool. 70 milliamp hour battery. Yeah, okay, well. Okay, that's great. Okay, so what's the next steps? I want to be able to, we could look at doing triangulation. So right now we've got a cube. I could actually pass in whether it's triangulate we can say triangulate is false, so that should just keep going. But if I tell it to triangulate, instead of building polygons, I could, so if triangulate, for those who aren't aware, self, in a class, self is just the instance of the class, right? So this is all class based. I've got a class called cube, and so its instance will have, that's what self is talking to. Else we're going to do that. So what I could do is do self, and I'm passing in the graphics library, which is what this graphics is. So because it's a separate class, what I do is when I initialize my graphics library, and then I pass the graphics library to the cube. So the cube can talk to all the graphics routines. Didn't you make a YouTube video about the monocle? Subscribe to your channel after learning it. I'm saying. Did Chris? I don't know. Dot try, because if we do this, then I could do filled triangles. Triangle. Okay, so if I go, we're still doing the lines, but this is a little bit simpler. So I'm passing it 3 sets of XY coordinates. All right. So I'm passing it, for instance, I've got to do 2 halves. That one, that one. Let's start with those. So those 2, those 2, and obviously we need to choose which order the faces are in, and the color. Whoops. That's 1 triangle, and then we'd be going, so let's work this out. So 1, face 1, 2, and 3, and then we need 1, 3, and 4. 1, so it's 0, 1, and 2, 0, 1, and 2, 0, 2, and 3, 0, or it could be 2 and 3, 3 and 2, doesn't really matter, 3 and 2. So maybe that won't crash. Cube has no attribute triangulate. What? What do I call it? Triangulate. Self.triangulate equals triangulate. Okay. Thanks, Johnny. Okay, so now if I tell it in here, I can tell it to go true for triangulate. We have a triangulated cube, which the distortion is making it look terrible. Let's go back and fix this. Goes back to 3.5. Okay, so we have a triangulated cube now. Which means I could also, oh God, I could actually tell it to be a filled triangle. Oh, let's do 1/2 of it filled. This will slow right down, if it works at all. Right, so there's no shading, so it's just flat color. Alright. Z buffer. Dude, we don't have enough. Yeah. We don't have enough speed. What I can actually do is field and do color. I'm just bad hack. I'm not passing it 2 colors right now. There you go. There's rather than a Z. Look how slow that is. We're down to 6 frames per second now because how expensive it is to fill a triangle. Because it's just doing lots of lines. Can you make the filled faces with different face colors? Not right now. Yes, sure. Like right now, I'm just like, yeah. So, okay, I could do this. I could go. Value must be in bytes. Ooh, an error. Don't know what that was. What I can do is just for now, I'm going to create some colors in here. Self.face colors equals. I just need 6 of them. 50, 100, 150, 1, 2, 3, 4, 5. 40, 80, 120, 160, 200. Okay, and here I'm just going to tell it to be face colors and the index. Okay, so this should give me just a really bad version of, there you go. Oh, are we missing a face? We're missing a face. Or is that just flipped? That looks, okay. So we've got a draw. Yeah, we need to do Z buffer now because we're doing a drawing. The order is not back to forward. So yeah, this isn't going to work without a Z buffer. Yeah, no, it's just, yeah, it's yeah. So it wasn't really designed, but if I put it back to triangle, not filled, that looks a little bit better. I could also just, you know what, I could just do J times 30 for the colors rather than building a, I thought if I did that as an array, I could pass in the color list. Yeah, okay. No, there's still, looks like there's a, like the red one, so there's still like it's missing. Oh, it's just redrawing the same line. See, that's another thing. So I'm drawing lines multiple times, right? So if I stop this rotating, if I just go 0, 0, 0, and if I offset it at the start, 45. Okay, so if I look at this as a cube, now let's just make it bigger. Okay, if I look at this as a cube, every line is being drawn multiple times. So this line, can you guys see my mouse? I don't think you can see my mouse. No, you can't see my mouse. That's really frustrating. What am I doing? So each line, even if it wasn't, except for the center of the triangle, although even that's been done twice, every line's being done at least twice. Because for each triangle, it's going to redraw its own line. This could be sped up dramatically if I only ever drew the lines that hadn't been drawn. But like doing a Z depth would be faster. No, would be better, but I don't have. I don't even know how to implement that. Not at the top of my head right now. So what I could, I'm just trying to think of like cheap options for, I'm just going to turn triangulation off. So even with a cube, every edge is being drawn twice. For one face and one for the other face, that line along there is getting drawn twice, which is just silly. But what I wouldn't mind seeing is, can you sort the faces? No, well, yeah, that needs a Z depth. That needs some more sophisticated maths. But maybe, no, how would that know? Yeah, that's what it needs. It needs like a Z depth. It needs to be able to calculate that in one pass, and then do an order to build it. But yeah, that's how it would be done. I off the top of my head, like it's been 30 years since I've ever written any 3D type of stuff. You know, when working on games, even 3D games, you don't write your own 3D graphics engine. You use the game engine's 3D library. Now, if it's a list of points, it doesn't know what order they're in. It doesn't know, like, you understand, like, and yeah, it's sorting them in that order. You need to do, you do each one through what's called a Z test, and it's got to be a separate pass. Like, you can't do it all in one. Like, you need to say, okay, this is what I'm going to build. These are all the points of my shape, right? Now and they can't just be points in an array. You need to know what they are, because they need to be shifted, right? And they need to be shifted, but based on their polygon. You can't just say this point has to be first, and then this point has to be last, and reorder them, because then it doesn't know how to build the polygon anymore, how to build whether it's a triangle or whatever. So right now I've got a representation of a vertex, but I'd need to actually do a representation of a triangle, and the triangle would have to understand its vertices, and then for instance, a quad, I'd need to be able to build a quad, and a quad would have to understand its triangles. That would be the only way to do it, right? It's not just as simple as taking what I've got and ordering it, right? Right, so the only way that would work with a Z buffer is I need to write all that stuff into a separate buffer, where that buffer isn't just color data, it's color data and XY. Sorry, color data and a Z position, right? And then again, I still have to go through a pass and change it. So, yeah, it's usually done with triangle. Right, it's done tessellated faces, right? Ultimately, everything is a triangle, even pixels for most graphics cards these days. Like a modern graphics card doesn't know what a pixel is, right? Every single thing it draws is a triangle. And if the triangle is 1 pixel in size, then you get a pixel. But it's much faster. The whole pipeline, the graphics pipeline, the hardware pipeline is designed about building a triangle as fast as possible, right? Because a triangle makes any shape, like if it's a faceted shape, right? Everything gets broken down to triangles. When I say every modern graphics card, I'm sure that they've got all these crazy techniques now that do things that are whatever, and it's all done at the shader level. But anyway, the point is, I'd have to extrapolate this out way further to be able to do that. Like right now, it has a list of vertices and faces, and they're not attached, right? If these vertices are moved, then and reordered, then the faces have to be recalculated, right? To know which order to build them. What I was thinking of doing was, it'd be really cool if I could do a gradient on a line. If a line knew its depth, I could do some fake shading. It still wouldn't be in the correct order, but it would lead, but like I could make it maybe look like it was darker going backwards, but that seems like a wasted effort as well. Okay, what about, so if I go, I just typed in Python Z depth calculation. I don't even know. I'm calculating it. It's writing all the stuff into a buffer. It's called frame buffer, John. And then that frame buffer is pushed every frame to the FPGA frame buffer. So it's the pixels buffer. There's one on CircuitPython side which gets pumped position for pixel for pixel into the ICE40, and the ICE40 is constantly taking what's in its frame buffer and putting it on the screen. Yeah, this is that was a plot 2D image and 3D plot. I wonder how much of this can be done in OpenCV, but anyway, I don't ask ChatGPT anything. Not anymore. Python triangle Z depth calculation. Ooh, tiny 3D renderer in Python with Z buffering. What? What? In less than 200 lines of code. What? Otaku, right, except the problem with that is, what's if some of it is visible, but most of it's not, right? You need to then also be able to detect whether things have been obscured or not. So, I don't know what this is though. So I'm just, we'll build a functioning 3D render with adjustable camera direction. What? Z buffering to accurately present overlapping triangles. No way. Oh, so they're using NumPy. Okay, and pill. Whatever. So 3D object. See, it's a set of points of triangles and colors. It's got to work off triangles. They've got a renderer, camera picture. Oh, wow. This is... See, that's what I want to do. Okay. Exploitation Y. So they're using a NumPy matrix to do it, but they're still using cosine sine and whatever. I want to know how they're doing the point triangle. Yeah, see, that's the problem. Moving the triangles that don't face the camera. my god, this is bringing back awesome memories. Z buffering. Yeah. Hey, Loki. Yeah, it's been a long time for me as well. I mean, I wrote a 3D renderer forever ago. Back in the day. Right, and then you need to put normals on them. So you need to know which way the triangle's facing, so it needs to have a normal. And that's the winding, right? So if a triangle is wound one way, it's facing this way. If it's wound the other way, it's facing that way. And then, you know, if it's facing towards the camera or away from the camera. It's complicated, right? So this can all be done. I mean, this looks great. This looks like, except for all the NumPy stuff. That would all have to be ripped out because that's not... I mean, they're fast arrays, right? So what's nice about NumPy, really, is that here's an array, and that's actually in C++ in the back end, right? Inside NumPy. Not really a different thing. It really depends on what it's being used for. If it's being used for light bounce off to do normal mapping and stuff, sure. But for basically for... Anyway, it doesn't matter. It's 3D renderers are way more complicated than this. It really depends on what you want to be rendering. Yeah, shaders, we don't worry about shaders. Anyway, this looks pretty cool. Maybe I'll have to give this a go at getting it in. There is a thing called ULab, which is like a orthodontist. No, that's not it. ULab NumPy. So it's a it's like NumPy or NumPy, whatever you want to call it, but for microcontrollers. So it's cut down quite a lot. And again, like you've got this C array where it stores stuff in that. So I'd have to build a version of CircuitPython with ULab. I don't think it's got it built in. Yeah, yeah. Hey, IBH. MSC 1V8. You're right. I mean, I'm not even considering rendering things that are complex faces right now. It would be like silly doing that in CircuitPython, I think. Sure. So I'm pretty sure CircuitPython ULab. It's under core modules. Really? Oh my god, it's got ULab built in. Equals ulab dot numpy dot array. Oops. Missing one positional argument, but okay. Wow, okay. I didn't realize it has that built in. Okay, well, I don't have time to, like, it's as I said, it's going to be a shortish stream today. Short-ish, it's already been an hour 20. I don't have time to try to get this working today, but this is really cool. I didn't expect to find... I should have done that from the start. what I should have done when I started this last week was, hey, I wonder, is there a 3D library for Python that I could convert and use that rather than trying to build all this from scratch from memory? What a freaking idiot. Oh my God, that's like days of my life I could have saved. Look at this, I could have got something like this happening. Hey Chris, look, it's you. It does look a little bit like you, Chris. Kind of. We've all been there, yeah. Silly Sion. And I didn't even do a good job. I mean, look, it works, right? When I say I didn't do a good job, like it's not the best code in the world, but it does work. Oh. Really? Why is it just not letting me? Oh, there we go. Right. Hi, Yaz. Oh my God, I'm streaming. Don't even ask. You did wake up this morning when I got up. You looked at your clock. Do you remember? It was 4:45. Don't ask. Anyway, I'm streaming, but I'm going to wrap it up now. I need to get back to work. But, yeah. Look, I'm just playing. As I said, if I was taking this really seriously, I wouldn't be doing it in CircuitPython. I love CircuitPython. I love Python, MicroPython, and Python. Like, don't get me wrong. And clearly, you can do some stuff in it. It's not like, you know, this whole can't do anything. It's got to be in C. But if I wanted like a fast performant thing, it'd have to be in C. But I'm curious to see with ULab. Because ULab is, again, all the functions and all the containers and everything for it are on the C side, rather than, like right now, all of my arrays in Python, in CircuitPython, they're living in the Python side. So they technically have to be copied down all the way for the ESP32 to use them every time, right? Yeah, last week I was trying to get it to render fonts. I can get it to load any font now, by the way. As in any of the Adafruit fonts, the BDF fonts. So I can just grab a BDF font, put it down. Up here, that's the one I've loaded, but I can load any of them. So I've got both font things implemented. I've got the 8-bit font, so the 8-pixel font, Deshipu's one. That's the one I'm using for the frames per second up there, and I can also, I could technically, I could just do this. Text custom. There we go. Now we've got big, see, I can just switch out between the two different fonts. So this is using the more expensive font, and that's as a gradient. You can use the same font on your feather thingy. Yeah, I know. Do you remember, this is all pixel doubled, which is why it makes that small font look a bit yuck. I'm hoping for something built into the FPGA. You really need to mess with programming FPGAs. Sure. I mean, so the plan is, I'm saying when. It's not an if when. It's not an if. It is a when. I can't tell you when. The plan is when I eventually get the BlizzardS3 out, like all of the Bitstream stuff we're working on and all of the, everything like I'm playing with will just be open source in GitHub. So, the I don't know if it's Verilog or whatever Michael's written it in, like the whole DVI out stuff will be there in code and a bitstream and whatever. You'll be able to like part of me playing with this is because I just want to have some fun, but I also want to just build a bunch of stuff that I can put on GitHub, so people with a BlizzardS3, I mean, technically you could do this on other boards, but people with a BlizzardS3 can just grab this code and put it on and play and have some fun. I want to just have a bunch of, even if the code doesn't do anything specific, like spin a cube, it'll just be there for people to play with and hack away at. And obviously would love community input back in stuff. As I said, my BlizzardS3 board, when I release it, will be open source. So, you know, if people want to hack the hardware, they can. If people want to hack either side of the code, they can. Whatever. So, thanks, Otaku. I'm gonna call you Otto. Otto for short. I won't even remember that. Okay, I'm gonna go. I didn't get a lot done today, sorry, but whatever. It's a start. This thing looks really cool. I don't know when. Maybe next week. No, I want to get this in. I don't want to do that next week. I want to have that in for next week. Maybe we'll see. I don't know. Yeah, lots of other things. Anyway, I'm going to go. Thank you all for joining. And sorry about the last minute stream again. Unplanned, but I'm glad I did. But I need to go turn the line on, and I've got 4 trays. I've gone through a few of them. 4 trays like this of boards to test and pack. This is only tray number 1. And that's only yesterday's manufacturing. I've got a lot to do today as well. And that was the last packet of coffee. So once I run out of coffee, I'm going to be in big trouble. I've left this here so I can remember to order some more. Okay, bye everyone. Catch you all next
John
week.
Clayton says, great live stream. I love it when I get home from work on Tuesdays and get to join this fun chat.
Thanks, John. It's good to have you here too. It's good to have you all here. Okay, I'm going. Got to stop saying goodbye. Bye.